Okay, so for today's video, we will be discussing some concept about the inverse function, right? So let's have a look for the learning outcome. We have to understand the term, what's the meaning for one-to-one function, and also what's the meaning of inverse function. Okay, and after that, before we can find out the inverse function, right, we need to determine whether the function given is a one-to-one function or not. If let's say it is not a one-to-one function, then the inverse function will not exist. Okay, and of course, we need to learn how to find the inverse function for this one-to-one function as well. Then after that, you'll need to learn how to sketch the graph. Okay, so what is the meaning of the function and also the inverse function in terms of graph also, right? Okay, so let's start. For this 2.6 inverse function, okay, when we are having a function f that maps x to y, the inverse function is denoted by f inverse. Okay, so f inverse, you can see that the symbol is f power -1. And then you need to understand that this f inverse x is not having the same meaning as 1 over fx. This is not the same meaning, all right? So the f inverse here actually means the inverse function, but the symbol look like this. So don't misunderstand or confuse it with 1 over fx, and they are not the same thing, right? Okay, so to have the inverse function, if let's say we draw in an arrow diagram, right? Let's say I'm having a set of domain, which is the x, and also a set of domain, a set of range, a set of data with a range, which is the y. So if I have a function f that maps x to y, which means that I'm having something like this. So the arrow diagram for the function f will be something like this, where we denote that this is the x and this is the y. And then what's the meaning for inverse function? Inverse function means the opposite, okay, the opposite way, the opposite direction of the function, which means that we are trying to map the y, go back to the x. And we call this as inverse function, f inverse, okay, x. All right, so in arrow diagram, this is how we denote the function f and also the inverse function. Okay, all right, and then after that, we need to know that for this particular circle, right, this particular set of x, we know that it is the domain of the function because this is where we start, okay, to map the x to the y. So the starting value will be the x, will be the domain of the function f. And then for the second set of values here, this one is actually the range of function. Okay, but if we have a look in terms of f inverse, right, this set of data or this set of values, the y, right, basically belongs to the domain of the inverse function, right, because this is where the inverse function starts. Therefore, I can also write that the same set of data here, the same set of element here will be actually the domain of the inverse function. And of course, for this set of value, it will be actually the range for the inverse function. And you can see that from here, we can see a simple conclusion where the domain of function should be equals to the range of inverse function, and the range of function will be equals to the domain of the inverse function. Okay, so you can have a look here and then you can try to compare, and this is what we can see, right? Okay, therefore, this is the result that we have. Okay, so this set of result, basically we get it from the idea from the arrow diagram. Okay, so you can see very clearly that this set belongs to the domain of function, and also it belongs to the range of inverse function. So these two set of values should be the same. Okay, then the range of function should be equal to the domain of the inverse function. All right, and this result is very important because for our syllabus, right, we actually been tested a lot on the concept of domain and range. Therefore, please make sure that you are very clear about this. All right, so let's proceed further. After we roughly know what is the meaning for domain, what is the meaning for function and inverse function, then let's continue here. Inverse function, right, only exists with one condition where it is a one-to-one function. When the function is one-to-one function, then only we will have the inverse function. Okay, so maybe previously when we learned about the inverse function, right, we are not very much focused on this. But for now onwards, please make sure that you are very clear that inverse function can only appear or exist when it is a one-to-one function. Then how can we know that the function is one-to-one function or not? So there's a simple way for us to test on it. So to test whether a function is one-to-one, there's a horizontal line test, okay, can be used. So we are using the horizontal line to check how many intersection point do we have. If let's say there's only one intersection point of the horizontal line and also the graph, then the function will be a one-to-one function. But of course, this is just a very simple way of determine whether the function given is one-to-one or not. All right. And after you decide and determine that, oh, okay, this one is one-to-one function, then only you can proceed to find out the inverse function, right? Okay, so let's have a look for one example here. Okay, so for example 26, they want us to determine whether the following functions are one-to-one function or not. So if you have a look for part A and part B, right? Both functions here are having the same equation or same expression, which is x squared, just that the domain are different. All right, so if you have a look, how can I know that which one is one-to-one function and which one is not a one-to-one function, although the expression are the same? Okay, so for part A, if I want to sketch the diagram x squared, so this will be my x squared, a U shape, right? Okay, this is my x squared. And then I'm drawing it for the complete U shape, the smiling face here, because of the domain given is belongs to the real number, that means from negative infinity to positive infinity. So when I draw it, if I want to determine whether is it a one-to-one function, I will draw a horizontal line anywhere or along the graph, right? Then you can double check and see how many intersection points do you have. So I think very clearly we can see that there are two intersection points can be seen between the horizontal line and also the curve for x squared. Therefore, you can say that this is not a one-to-one function. Right? And then how about for part number B? So for part number B, I'm having still the expression x squared. So by right, it will be still looking like a U shape, right? Okay, it will be still looking like a U shape. Okay, and now, since they are saying that I only want to consider the domain where x greater equals to 0. So if I consider only the x greater equals to 0, that means I only want to consider this part of the graph. Okay, so my final graph will look something like this. I only want the half part of the graph here for the complete U shape, because this is the domain for x greater equals to 0, right? Okay, then now, again, to test whether is this a one-to-one function or not, I will draw a horizontal line anywhere along the graph. Okay, so after I draw the horizontal line and try to move it up and down, so I can see that no matter how high I move it or how low I move it, right, there's only one intersection point, okay, for this particular curve. All right, therefore, here I can make a conclusion that this is a one-to-one function. Because there's only one intersection point between the curve and also the horizontal line. All right, so you can see that although we are having the same expression, which are also x squared, okay, but because of the different domain, the shape of the graphs, looks a bit different. So for the first one, I'm considering the whole U shape. The second one, I only consider part of the U shape. And when I draw the horizontal line, first part, you can see very clearly that there are two intersection points, okay, between the curve and also the horizontal line. And for the second graph here, there's only one intersection point between the horizontal line and also the curve. Okay, so from here I can make a conclusion that this one is not a one-to-one function. This is a one-to-one function. And when it is not a one-to-one function, right, for this particular curve, for this particular question, we cannot find the inverse function. Inverse function does not exist. Okay, and then for this one, of course, the inverse function exists because this belongs to one-to-one function. Right, so to make sure that the inverse function exists, right, we actually need to make sure that our function is a one-to-one function first before we can find out the inverse function. Okay, then this is just a simple way to determine whether the function is one-to-one or not. All right, so in exam, you just need to imagine in your mind, you don't need to just you don't need to draw out and then to decide, you don't need to show. Okay, but you can just try to imagine the graph and also the horizontal line in your mind, and then you figure out whether is it a one-to-one or not one-to-one function. All right, okay, so this is a simple introduction on the one-to-one part, one-to-one function part. Okay, then now let's proceed to the next part where we try to find out the inverse function. Okay, so to find the inverse function, there are a few ways. All right, so there are many ways that you can use it. Some students, they will use the formula f inverse x equals to x, where they are using the composite function. F composite with f inverse x equals to x. So this is a composite function technique. All right. And then if you want to know how the composite function works, you can go and review back the previous video, right? But I forget which is the video already. And then now by substitute, the second method is by substitute fx equals to y. Then you try to find x in terms of y. Also can, all right? So there are many ways that actually these are two suggestions here. Okay, then for me, usually I'm using this one. Okay, maybe I try to, usually for me, I will try to avoid the composite function method, but both are actually correct. They are not like super hard or what, but you can choose anything that you like, right? Okay, so usually for me, I'm using substitute fx equals to y, then I want to try to find out x in terms of y. Okay, so let's have a look for some example here. We will start with example 27 first. Okay, so a function f is defined, okay, for this one. Okay, the domain given is from 2 until 4. They want us to find an expression in terms of x for f inverse and find the domain of f inverse. Okay, so first to find out the inverse function, when they ask us to find the inverse function, most of the time it is already a one-to-one function, so you no need to purposely go and check anymore. But if you want to do it for better understanding, of course, you can go through it, right? But when they ask us to find the inverse function, they already set the question to be a one-to-one function. All right, so I will let y equals to 2x minus 3 power 3 minus 8. So this is my original function. When I want to find the inverse function, right, I will change, this is now y in terms of x, y equals to something something x. And to find the inverse function, I will rephrase it to make it become x equals to something something y. All right, so what I'm going to do now is this one. I move all the numbers to the other side. So 2x minus 3. Power 3 here, when I bring it over, it will become cube root. Right, then I'm having 2x equals to 3 plus cube root of this. And then further simplify, I'm having this. And now you can see that my solution here, I'm changing y equals to something something x, become x equals to something something y. So this one basically will be my inverse function. All right, and usually when we want to rewrite again, we write in terms of f inverse x. So for f inverse x, I want to put everything in x, variable x. So I will change the y become x here also. So this is how we find out the inverse function. Okay. All right. Then after that, let us continue to the next part of the question. After find out the inverse function, they want us to find the domain of inverse function. So again, just to recall back, to find out the domain of inverse function, right? You need to recall back that it is actually equals to the range of the function. Okay, so please remember this result here. To find out the domain of the inverse function, I need to find out the range of the function first. So how can I find out the range of the function? To find out the range of the function, if you have a look here, it is actually a cubic equation. So the cubic equation, no matter how, it will look something like this. After you sketch it, it will look something like that. And then the domain given is from 2 until 4. So this is 2 and this is 4, let's say. If I want to know the range, right, I need to know what's the value for when substitute x equals to 2, and also where's the value of y if I substitute x equals to 4. So this particular part will be your range of the function. All right, so again, to determine the range of function, right, most of the time we still need to imagine the graph in our mind so that we roughly know what is the range of our function here. Okay, so once I know that I need to substitute the value 2 and 4 into my function to get the range, all right, so I will start showing it now. I will want to substitute f2 inside. When x is equals to 2, what's my function here? So I'm having 4 times 3 power 3 minus 8. So you're having 1 minus 8, which is negative 7. And after that, I want to substitute 4. 4 times 2 is 8, minus 3 power 3 minus 8. And then from here, you should get quite a large value, which is 117. Okay, since I know that the range for the function is from negative 7 until 117, right? Okay, from here, I know that this is the range for the function actually. And since I know that the domain of the inverse function is also equals to the range of the function, therefore, the domain of the inverse function, right, when I write it out, I'm having also negative 7 until 117. But for the variable here, I'm changing it to x because when we are talking about the domain, right, it is actually referring to the value of x, okay, not the value of y. So range is the value of y, but domain is the value of x. Therefore, you can see that I'm trying to write it in terms of x. So the x is between negative 7 until 117. Alright, so this is how a question that involves inverse function will look like usually. You need to understand how to change an original function become the inverse function, and also try to link the concept of domain and range for original and also the inverse function. So for this example, I'm using domain of the inverse function is equals to the range of the function. Alright, okay, so this is our very first example of inverse function. It is in the function of cube root, the cubic function, okay, with x power 3. Right, so we will proceed to the next example, where next example we are going to discuss about the inverse function in quadratic. And please make sure that you are very clear, okay, how to find out inverse function in quadratic function, because it is quite commonly asked or quite frequently asked in the exam. Maybe for the exam style question, you're aware that they seldom ask about the cubic, but they actually ask for quadratic inverse function very frequently. It is because of they can play around with the domain and range for the quadratic function a lot. So make sure that you are very clear on how to find the quadratic function, the inverse function of the quadratic function. Okay, so let's look for example 28. So I'm having this function here. It is a quadratic function, I think very clear. Define for the domain x greater equals to 3. So first of all, they want us to express this in this form. So this is actually the complete square form, right? So you have to try completing the square, and then only we continue to the next part. So to complete square, so I hope that you are very familiar with this already. Okay, you can have a try. So to complete square, I need to plus something square minus something square. And the something here will be actually negative 6 divided by 2. So I'm having negative 3. Then I combine the first 3 terms together, become one big bracket with a square outside, then minus 9. So this will be our completed square for this quadratic expression. Okay, and then how about part number 4, the next part? Alright, so for the next part, they want us to find an expression for H inverse and state the domain of H inverse. So maybe let's have a look for the H inverse first. Okay, every time when you want to find out the inverse function for a quadratic equation, right? There's only one way where you must go through with complete square of a quadratic function. There's no other method. Alright, so every time when they ask you to find out the inverse function for any quadratic expression or quadratic equation, right, please make sure that you try to complete square it before you continue to find out the inverse function. Okay, so to find the inverse function, again, I will let y equals to the original function. This is my original function, but of course, I don't want to use it. I want to use the complete square method, the complete square form. So I change it become this one, which is x minus 3 square minus 9. Okay, so again, I want to rephrase it from y equals to something something x become x equals to something something y. All right, so I will slowly move everything over. Then I'm having y plus 9 equals to this one, x minus 2. And then when I want to make the square disappear, I need to take square root, right? So when we take square root, we have to include both plus and minus sign. Okay, so you can see that the plus and minus sign is very important here. Please make sure that you include it in your solution. When you want to take square, make the square disappear, you have to take square root. When you take the square root on your own, you need to consider both plus and minus sign. Okay, so I think I make a careless mistake here, right? This one should be a 3. Okay, then after that, I want to make the 3 over. So I'm having x equals to 3 plus minus square root of y plus 9. Okay, so maybe until this step, we consider quite complete already our step. Okay, so from y in terms of x, I change it become x in terms of y. Okay, but now we have a problem. Huh? For this answer, right? Basically, we're having two answers here. The first answer is 3 plus square root y plus 9. And this one is 3 minus square root y plus 9. Okay, so we are having two answers here. But in our solution, we must have only one answer. We cannot include both plus and minus in our solution. Therefore, between these two solutions, right, I have to choose one, which is the correct solution. So how can I choose the correct solution? All right, maybe previously when we learned, we just include both one as my answer. But now, because we are talking about domain range and also the complete definition for inverse function, so we actually need to choose only one correct solution from that. So 3 plus something and also 3 minus something. All these belongs to the range of F inverse. Okay, so all these belongs to the range of F inverse. Okay, therefore, if you want to decide a correct range or the correct formula for the range, you need to refer it to the domain of the function. Because the range of inverse function is the same as the domain of the function, right? Okay, so what is the domain of the function in this example? So the domain for the function in this example is this one, x greater equals to 3. Okay, therefore, my range must be also y greater equals to 3. Okay, y greater equals to 3. So to decide the correct function, you need to ask yourself, I'm having 3 plus something. This value inside the square root can change, right? Okay, so in short, you can see that it is actually 3 plus something, and this one is 3 minus something. 3 plus something will give you an answer that's more than 3, or 3 minus something will give you the answer that's more than 3. Definitely it's 3 plus something, right? Okay, because the square root here, the value for square root is always positive. So 3 plus a positive value, it will be always more than 3. Therefore, it fulfills the domain of the function. But if you're having 3 minus a positive value, 3 minus something is always less than 3. Therefore, it does not fulfill this domain here. And from here, you can see that this is the correct range or the correct final answer for the inverse function, and this is not, because the first one actually fulfill the domain of the function. All right, so after you choose and decide the correct function already, then you rewrite your equation again. The inverse function of h will be actually equals to 3 plus square root and then x plus 9. Okay, so the other one with the minus 1, I will not include it in my final answer because I can only choose one correct answer for the inverse function. So this is what we have for a inverse function for quadratic expression. And usually we will be tested on this quadratic inverse function because we need to learn how to choose the correct function out. All right, okay, so this is the guideline how we select the correct inverse function when we are having the quadratic expression. Okay, so after we are done with the inverse function part, and then now they want us to state the domain of H inverse. Oh, sorry again. So this one now, I shouldn't write F inverse, right? I should write H. Okay, then now let's have a look at how to find the domain of H inverse. Again, To find out the domain of the H inverse, I want to link it with the range of the original H of the original function, right? So this result we learned it earlier already. So the domain of inverse function equals to the range of the original function. I want to know what is the range for the original function. So to know the range for the original function, I need to look at this one. This is my original function. After completing square, this is what I have. And then from here, I roughly know that it is actually a U shape, the smiling face, right? Because of the coefficient here is a positive value. And then after that, I know that my minimum point will be 3 and -9. So that means this is my minimum point. This is 3. And then my graph might look something like this. Okay, my graph didn't follow the ratio, so it will look a bit weird, but never mind. This is a -9. It will pass through the 0 and also the 6. Okay, then for this particular curve, the domain given is x greater equals to 3. That means I only want to consider the graph when the x is more than or equals to 3. That means the graph that I accepted will be this one. Only the green color part, only half part of the graph. Therefore, you can see that it is a one-to-one function, right? That's why you are allowed to find the inverse function. Okay, from here, because you can see it is clearly that this is a one-to-one function already. Okay, then again, our aim is to find out the range for this function. So where's the lowest point for the function here? The lowest point here is this one, -9, and then the graph will be going up, right, constantly. Will be going up, all right, continuously. Therefore, this is actually the range of the original function h. So the lowest point is -9. Therefore, when I write it out, it will be y greater equals to -9. Okay, and since the range is y greater equals to -9 for the original function, therefore the domain will be the same as well. So when I write it out, I will write it as domain of h inverse. It will be also greater equals to -9, but because of domain, we are talking about the value of x. Therefore, I will put it as x greater equals to -9. So this is how we decide the domain for the inverse function. All right, so you can see that when solving all this kind of question, you need to have a very clear concept on the domain and range for both quadratic and also the inverse function for the quadratic. Okay, all right, so this is what we have for example 28, which is an important example because for our exam, they are always being asked, they are being asked frequently, I can say, the quadratic function and also the inverse for quadratic. All right, and then you can see that also we always need to have the concept of domain and range to decide the correct answer. All right, okay, so if let's say this question has no problem and you roughly have the idea on how to get the inverse function for quadratic, right? You can try out on yourself, for yourself, by yourself on example 29. You can pause the video here and then you have to try first. After that, only you come back to look for the solution. Okay, so let's have a look for example 29 now. Again, I'm having the function f. It is given like this, and the domain given is x can be any real number. So first part, they want us to express this again in the form of a plus x plus b squared plus c. Again, complete square form. Okay, so for this complete square form, what do I need to do is I need to factorize the coefficient of x squared first. Okay, then plus something square, which is -2, minus something square, which is also a -2, then plus 11. The plus 11, I put it outside, and I didn't factorize it. Okay, and then after that, I combine the first three terms, become a one big bracket, -4 plus 11. I'm having -8 plus 11. Therefore, I'm having a plus 3. I think you should be very familiar with the complete square, right? Completing square. So I'm not discuss in detail anymore for the completing square part. All right, so this one should be your answer for complete square. Okay, after that, they want you to state the range of f. So what is the range for this particular curve? Again, to find out the range, you need to always imagine how your graph look like. So our minimum coordinate will be 2 and also 3. So 2 and 3 should be here. Like this is 2, let's say. Then maybe this is 3. Okay, then when I try to draw the graph, okay, it might look something like this. If you want it to be more accurate, you can try to calculate this value. It should be 11. Yeah. All right. So this is how my curve look like, and then I know that this minimum value here is it's a 3. Oh, sorry. Not negative 3. My fault. So I think 2, 3 should be here. This one should be a 3, and therefore my curve should look something like this. Okay. So this value is a 3, and this y-intercept should be 11. Okay, so this is how my graph look like for this quadratic expression. And then when they're asking for the range, right? So from here, if you have a look for the range, the lowest value is 3 for the y. And the range of the function will be what? It will be y greater equals to 3 because the graph exists only above the 3, right? Above the value y equals to 3. Therefore, y can be greater or equals to 3. Therefore, this is my range. So I decide it by imagine the graph, okay, in my mind. So I'm having y greater equals to 3. Okay, then next, they are asking why the function does not have inverse for this example. Okay, why this function does not have any inverse function. So I think you can see very clearly, right? If I draw any horizontal line, you can always see that they are having two intersection points between the horizontal line and also the curve. So this is not a one-to-one function. Therefore, to explain it, you can just say that f is not a one-to-one function. Then next one. Okay, so every time when you ask why there's no inverse function for this particular function, it is because of very likely like it is not a one-to-one function. So very clear we can see from here, right? Because when you sketch the diagram, it is the domain which is x from negative to positive infinity. All right, so when you draw the whole U shape and you draw a horizontal line to test it, you can see that there are always more than one intersection point. Okay, therefore it is not a one-to-one function, and therefore there's no inverse function. All right, then let's have a look for part number 4. Okay, now we have a function g and it is defined like this. So you can see that the expression for the function g is actually the same like the function f. So what's the difference for g and f? It is at the domain part. So you can see that the domain for g is x smaller equals to a, where a should be a value, right? It's a constant. Okay, so first of all, they want to ask you to state the largest value of a for which g has an inverse. Okay, then now, maybe we need to refer back to our curve here. This is my original curve, right? When the range is from, when the domain is from negative to positive infinity. And now they're asking us, I want to decide a value of a so that it has a g inverse, g has an inverse. So to make sure that it is the inverse appear, right, or the inverse exists, you need to make sure that it is a one-to-one function. So to get the highest value for a, you have only two options. The first option is you consider the left-hand side of the graph. Okay, cancel off the right-hand side. Cancel off the right-hand side. Then you can see you can get the one-to-one function, and therefore you have the inverse function. Another option is you can choose to consider the right-hand side of the U shape. Okay, the right-hand side of the U shape, that means the green color part here, or the black color part here. Okay, where it is also a one-to-one. To consider this part of the graph, right, the domain written should be something like this. X greater or equals to a value a. Okay, then this one should be x smaller or equals to the value a. So which actually fulfill what the question want here. So they are asking for x smaller equals to the value a, right? Therefore, to consider the one-to-one function, we should consider this part of the graph. And to consider this part of the graph, right, the largest value for a is the line of symmetry, or the x-coordinate of the minimum point, where a should be equal to 2. Okay, that's the largest value. If let's say you consider any value greater than 2, then your function is not the one-to-one function anymore because you're having two intersection points at this particular part. Okay? All right, so the largest value that we can take for the A is actually 2. All right, so this is how we decide the value for A. So they just wanted to state the value. So A should be equals to 2. Okay, so from here you should know that X should be smaller or equals to 2. Okay, then the last part, they say when A is having this value, right, they want you to obtain the expression for G inverse and state the range of G inverse. Okay, so again, to find out the G inverse, I need to have Y equals to the original expression. And to find out the inverse for the quadratic expression, you need to let Y equals to the completed square form. It must be started with completed square form, all right? So the completed square form answer, I take it from part 1. Okay, then I slowly move the numbers to the other side. Okay, so I'm having x minus 2 equals to y minus 3 divided by 2. Then I take the square root. So when I take the square root, I need to consider the plus and minus sign. Okay, and after that, I'm having this. Okay, then again, I'm having two answers here. One answer is 2 plus square root something. Another answer is 2 minus square root something. And this is the range for the G inverse. To decide the range of the G inverse, I need to refer back to the domain of G. So what's the domain of G? So just now we already know that domain of G is x smaller equals to 2, right? So for x smaller equals to 2, I need to ask myself, which one will give me x smaller equals to 2? 2 plus something will give me x smaller equals to 2, or 2 minus something will give me a value smaller than 2. So I think very easily you can see that this is the correct answer and this is the wrong answer, right? Therefore, I need to rewrite again for my correct inverse function of G, where I want to take 2 minus this whole thing, so that I can get a value that's less than 2. Okay, and after that, they want us to state the range of G inverse. Again, recall back, the range of G inverse is equal to the domain of G. And I think we can see very clearly that the domain of G is already given here, right? X smaller equals to 2. Therefore, the range of inverse, G inverse will be equals to smaller equals to 2. Okay, but because of we are talking about range, so the range is actually related to the value of y. Therefore, when I write out, I have to change the x become y. So I'm having y smaller equals to 2. So all these are some example, okay, that is related to the inverse function on quadratic expression. To me, I think it is quite there are some points that you need to really take care of. So it will be good if you can try a few more examples on finding the inverse function of the quadratic expression so that you know the process, you know the details like how to choose the correct inverse function, you know to link what's the relationship between the range and domain for the original and also the inverse function. All right, so we'll stop here for this video. And next video, we'll be discussing about the graph between the original function and also the inverse function.